Okay, good morning, guys. I think I had to start from here. Today, I'm not going to use my XP Pen because I don't have drivers for this laptop. But next day, I'll install the drivers. I need our department's permission to install the drivers. Okay, so today I'm not going to using the XP Pen. So I'll try to tell you if I have to write something. Okay, sorry for that. Uh, okay. Did you guys try to do the homework? Doesn't matter. I think due date for the homework set one, maybe next week. I hope. Okay. Uh, Due dates normally I assign for Saturdays. Yeah, Saturday nights. Okay. So most of the time you will be having like 1 or 2 weeks, but uh, please be noted that all the homeworks are already open. Okay. So if you know uh, anything, you can start any homework. Okay, doesn't matter. Okay. Sample mean I last minute last day last few minutes I discussed this sample mean. It is a average of the observations. Uh, how we get that? Summation of all the all summation of observation values divide by number of observations. Okay, values sum of values divide by occurrences, number of occurrences. Okay, that's how we get the mean. uh, this is the idea behind the mean. It is the balance point. uh, uh, okay. uh, okay, this is an example. If you have this kind of observations, there are 7 observations. Simply get the summation of these values, divide by 7. Why 7? Because you have 7 observations. Okay, so we denote it by x bar. X bar denote for sample mean. Sample mean. Now we are dealing with samples. Okay, that's why sample mean. Okay, it is simply mean. Since we are using sample, we call it sample mean. Okay, okay. Uh, Median. The other location scalar or location measurement is median. We denote by x tilde. Okay, tilde. Sample median. Why sample? Again, we are using a sample. That's why sample median. Median is the midpoint of the distribution. Okay, for the median, it doesn't matter the value. Always we try to find the location. What is the middle point? Okay, you will see later. This for to find the median, first of all you have to sort your observations. I would say either ascending or descending. It doesn't matter, but you have to sort in the first place. Okay, then you have to find the middle position in that ordered observation. Then go to that position and consider the value. Okay, that's how we get the median. Okay, median is a value. Yes, it's the value, but first you need to find the position, then pick the value in that position. Okay. um so first, order order your data set. Normally we do it in ascending order, but for the median, you later you will see that it doesn't matter whether we do it either ascending or descending. Doesn't matter, but anyhow you have to sort your observations. If n is odd, which means if we have odd number of observations like 9, 11, 13, something like that, what we have to do is simply we can pick the middle point. You can pick the middle point by using n plus 1 divided by 2. You can find the location. You can find the position. N mean number of observations in your data set. For an example, if you have 9 observations in your data set, n is 9. So n plus 1 is 10 divided by 2, which means 5. So your median is in the fifth location. 1, 2, 3, 4, 5. Pick the value in the fifth location. Clear? I cannot write it here, but n plus 1 divided by 2. That's give you the location. Okay? Go to that location and pick the value. Clear? That's the easiest way to figure it out what is the median. If we have even number of observations, then yes, still you can use n plus 1 divided by 2 find the location. But problem is if you have an even number of observations, you will be having like 2.5 position, something like that, right? Not the integer position. At that time, you have to pick just full integers before and after. Like if you have 5.5, 5.5 position, then you have to pick the value in the fourth position, sorry, in the fifth position and sixth position, get those two values, take the average. Okay, that's how we find the median if you have an even number of observations. Okay, I have, I think, two examples for those two cases. Here we have odd number of observations, 3, 7. Yeah, n is 7. So simply you can find the location. First, sort this data set. Okay, that's important. So n plus 1 divided by 2. N is 7 divided by 2. 7 plus 1 divided by 2, 8 divided by 2, 4. Fourth position, 1, 2, 3, 4, 155. So that's the median. Okay, clear? What happens if you have an even number of data? How many? 10, right? Yeah, 10. Okay, so n is 10. N plus 1 divided by 2. 10 plus 1, 11. 11 divided by 2, 5.5. So you have to pick first order it. Okay, ascending order. 5.5. So pick the fifth one and sixth one, get the average of those two. 1, 2, 3, 4, 5, 170 and 177. Take the average of those two, right? Which is, see, which is 173.5. Clear? Okay. Let me check the chat. What is this? Did I? Okay. In chapter 3 and 4, we will be discussing like mean of the population, especially population stuff. Right now we are dealing with sample stuff. Mean in the population, mean of the population, we denote by mu, Greek letter mu. But here, in this case, sample case, we denote by sample mean, we denote by x bar. Okay, so these are the general notations for population mean and population median. Okay, mu for the population mean, mu tilde for the population median. Okay, just keep that in your mind. Normally we use this notation so that you don't have to mention, okay, this is population mean, this is sample mean. Okay, once you use x bar, then I know that is the sample mean. Okay, those are standard notations. Okay, mean and median. There is actually there is a big difference between mean and median. Yes, those two are still location parameters. I mean, we measure our location using mean and median, but they have different behaviors. Like mean, since you have seen that mean always deal with values, observation, those observation values, so that mean is greatly affected by outliers, which mean it is outliers can be affected badly with this mean, because we are considering values. But if you are considering median, it resists to the outliers, because for the median, I told you, first we consider positions, not the values. Okay, that's the reason why this happens. Okay, so if you need to avoid outliers, if you need to avoid the outliers from our calculations, it's better to use median right now. Okay, rather than mean. Okay. Uh, yes, if mean and median, if they are approximately equal, which mean our data set is symmetric. Okay, symmetric. If it is almost equal, then we have approximately symmetric. If they are equal, then we have perfect symmetric shape in our distribution. Okay. I think next chapter you will see more stuff based on this. If mean less than median, it's gonna be left skewed distribution or left skewed observations. The other side, mean greater than median, we have right skewed shape. Okay, I think yeah. Oh, sorry. Do we need to? Okay, this is a summary. Uh, Skewness can be happen if median less than mean, this side, median less than mean, which means we have right skewed data set or right skewed shape. You call it a positive skewed. Okay. Same here, the second one, left skewed if mean less than median. If we have mean equal median, we have symmetric shape. Okay. Okay. Since we have a problem with mean, I mean, if we have outliers, then we have a problem when we are going to calculate the mean. As a solution, as a way out, we use trimmed mean, not mean, trimmed mean. We remove some considerable percentage, which mean a few values from the beginning and from the end, beginning and end. Uh, then we calculate mean of the rest of the observations. Okay, for an example, sort your data set. Then I'm going to remove first observation and the last observation. Remove them. Okay. Then take the rest of the observations. Calculate the mean. That's called trim mean. Okay. How we going to remove first or last? It depends on the percentage that we are going to introduce. Okay. When we are considering mean and trim mean is much better than mean. Okay, but still it is uh, less resistant to outliers than median. Still, median is the best choice we have. Okay. Okay. This is how we do the how we calculate the trim mean. If we have to, if we need to calculate alpha percent trim mean, alpha mean, it's a value 5%, 10%, something like that. With sample size simple n. I forgot to tell you. I forgot to tell you that sample size we denote by simple n. Okay. Population size we denote by capital N. Okay. Those are the standard notations. So first we need to calculate how many observations we need to remove. To do that, you can use this simple equation. Observations to remove from the one side equals to n times alpha over 100, which means n times 0.0 alpha. Okay, alpha percent. If you do this calculation, let's say this value n times alpha over 100 can be integer or decimal. Okay. So based on that, we have two cases. If we have integer value, if we have integer is at like 1, 2, then it doesn't matter. You can simply remove that value from the beginning and the end. If that value is, let's say, 2, then you remove first 2 observation from the from your data set and the last 2 observations. Okay, each side you have to remove that value, each side. Okay, if it is 2, first 2 and last 2, remove them. Clear? Yeah. Yes, you have to order the observations first. Clear? That's a very important thing. Okay. If you have a decimal value for the n alpha over 100, that portion, what you have to do is you have to do linear interpolation. Okay, we'll see that later. Clear? Okay. This example, I haven't mentioned the alpha value, okay, but I have mentioned remove first and last observation. So sort your observations into ascending order, remove first and last observation, remove them. Then consider what you have and simply calculate the mean. That's it. Okay. So number of now new number of observations are what you have. Okay. Here you have 1, 2, 3, 4, 5, 6, 7, 7 data, 7 observations. So without doing any trim mean, whatever, just calculate the mean. That's the mean. 170.6 is the mean. You have the median. Then order the data set. Remove first and last observation. So you have to remove 98 and 316. 316. You have to remove them. That's why I just crossed them. Now you have values from 100 to 204. Get the mean of those 5 values. Okay. Summation of those values 100 plus 140 plus up to 204. Divide by 5. Divide by 5. Okay. Not 7, 5. Clear? So that we have 156. So since I have given how many observations you have to remove, now you can calculate what is the trim percentage. Okay. Those calculation value n times alpha over 100 equals to 1 because we have to remove 1. Okay. You have to remove 1 from the beginning and the end. That's okay, but we have to remove 1 observation. So n alpha over 100 is equals to 1. Do the cross multiplication and you can find the alpha, right? So alpha going to be 14.29. So we can say that 14.3% trim mean is 156. Normally that's how we call it, because if you say trim mean, we don't know what is the percentage. What is that? We don't know. That's why we mention the percentage. This much trim mean is this. Clear? This is just an example. Sometime you may have given percentage. You have to find the trim mean. 10% trim mean is what? Something like that. Okay. I think there are 2 examples, so we'll go through them. Next case, if we have decimal value, so it is not easy to remove this one and this one. We have to do linear interpolation. You know, linear interpolation, the concept behind is when we draw a line in XY plane, we have a constant slope, right? Constant slope. So by taking the advantage of that, we can do this linear interpolation. Okay, that's the idea behind that. So if you consider if you consider the ratio between any 2 points, it is a fixed value. because we have a constant slope. Clear? That's the idea. So x and y and the blue color dot, x and y, those coordinates, not x and y. X we can find out, but we need to find the y. We have x naught, y naught. We know that. We know x1, y1. So use this formula and find y. Okay. We will see how to find that. This is our next example. I think it is already sorted. Yes. We have 3, 9, 10 observations. First, we need to find 10% trim mean. Okay. So n is 10. N alpha over 100. That's how we calculate how many observations do we need to remove. N is, I think, yes. Yeah. 10%. So n is 10. Alpha is 10. N times 10 over 100, which means 1. Okay. So you have to remove one observation from the beginning and the end, at the end. Okay. It is easy. It's a full, I mean, it's an integer value. So simply remove them, find the mean. So now new simple n is 8, not 10. Okay. 33 is the value. What happened if you need to find the 20% trim mean? Sorry, 20% or 15%? Oh, sorry, 15%. Okay. Sorry, 15%. Now we have a problem. If you do that calculation, you will see 10 times 15 over 100, which means 1.5 decimal. Okay. I mean, 1.5. You cannot remove 1.5 from the beginning and the end. Okay. So what you have to do is find the lowest and not the lowest. Find the adjacent full values, adjacent integer values. What are the adjacent values for the 1.5? 1 and 2, right? 1.5 in the middle of 1 and 2. So remove one, consider the left side. Remove one observation from the beginning and the end. Do that calculation, find the trim mean. Okay. Then consider the right hand side. 2. Remove 2 observations from the beginning and the end. Find the trim mean. Okay. At the end, you can get the 15% trim mean. I'll show you how, but that's the idea. Okay. You have to do the same process with different numbers 2 times. Okay. Clear? Okay. That's how we use the this kind of decimal. That's how we remove the decimal number of observations. Okay. We cannot do that. So we consider the integers. Yes. So 10 value is 1.5. So you have to consider 1 and 2. So if you need to remove 1, which means simply 10% trim mean, you saw that. Okay. It is this one. Okay. 1 mean 10%. Because we have 10 number of observations. That's why. So you already know that value. Now 2. If you do that calculation, you will see 2 mean 20%. That's why I mentioned 20% trim mean. Okay. 20 times 10 times 20 over 100, which means 2. Okay. That's why I mentioned 20% trim mean. So 20% trim mean, simply remove first 2 and the second and the last 2, get the mean from those 6 observations. You will be having 33.17. Now what? Do the linear interpolation. For the 10% trim mean, you know what are the x and y values. X value is 1. So the y value is 33. For the 20% trim mean, x value is 2, right? X value is 2. Where are they? Yes. And y value is 33.17. Okay. So here we have mentioned first x value is x naught, second x value is x1, first y value is y naught, second y value is y1. Okay. So those are the values. Plug those values into your equation. What about x? You know x because that's what you need to find. X 1.1, 1.5. So simply you know those values. Only unknown variable, only unknown value is y. Do the cross multiplication, isolate y. Y is 33.085. Okay, that's it. So 15% trim mean is this value, 33.085. Clear? So yes, you will be having a little bit more work if you have this kind of percentage, 15%. Like sometime you will be having 13 point. It depends on the observations. Okay, it depends on the number of observations that you have. Sometime you may have integer values, sometime not. But definitely you have to deal with that. Clear? Any questions? Now, we have to deal with very important stuff we call quartiles. Normally, when we sort our data, sort our observations, we can divide our data set into three pieces. These sorted observations or data set, sometimes observations I call data set, okay, or data. So once we sort our observations, we can split our data set into three pieces. Those pieces we call quartiles. We denote them by Q1, Q2, Q3. If we divide them, if we split them into three places, which means we have four pieces, right? Four pieces. So Q1 mean it represents first 25% from our data set. Q2, it represents first half or first 50% from our data set. Q3, it represents first 75% from our data set. Clear? Q2, I told you, it represents one half or 50% from our data set. Okay? Which means Q2 is our median. Okay, Q2 mean it's our median. Okay, second quartile is the median. Q2 means second quartile, which is the median. Exactly the same. First quartile, second quartile, third quartile, or second quartile you can call median. That's fine. Those pieces are equally distributed pieces. Okay, 25%, 25%, 25%, 25%. Okay, calculating quartile. First, you have to sort your data set into ascending order. First thing is, it's easy, find the median. Find the median, which means Q2, second quartile. Then, once you find the median, that median divides the observations into two equal pieces. Okay, two pieces. We call that first half. What they have mentioned here. Yeah, left half. First half for left half. The other part is second half for right. Yeah, right of the data set. Okay, clear? We have two pieces. So if we need to find the Q1 and Q3, what we have to do is find the median of the left half, or yes, left half. Median of the left half is the Q1. Median of the second part, or the right of the right part, I mean data to the right. Median of the median of this piece is the Q3. Clear? That's how we find the Q1 and Q3. Just cut the data set by its median, then consider those two pieces separate. Okay. If we have, in any case, if we have odd number of observations, then you have to add the median value to your uh, Q1 and Q2 calculations. Okay, I think I have mentioned it clearly in this example. So we have our data set. First sort the data set. Okay, first sort it. Sort the data set. You can see the observations from -12 to 7, +7. So find the median. How many? I think 4, 5, 6, 7, 13, right? 13. We have 13 number of observations. So find the median. 13 plus 1 divided by 2, which means 7, right? 7. So seventh position. 1, 2, 3, 4, 5, 6, 7. 1.4. So our median is 1.4. You can cut your data set from 1.4 and then consider I'll use left half and right half. That's the easy. So once you cut your data set from the 1.4, consider left half. Since you have 30, right? A odd number of observations, what you have to do is consider the 1.4 to your Q1 calculations, first quartile calculation, so that you will be having, let's say, first half 12, negative 12, negative 5.2 up to 1.4. There are 3, 6, 7. There are 7 observations. Clear? So find the median of that first half or left half. So 7 plus 1, 8 divided by 2, 4. Fourth position. 1, 2, 3, 4. Negative 1.5. Negative 1.5 is the median of that part. So Q1 is negative 1.5. Now consider right half, including median, because you have odd number of observations. Clear? So from 1.4 to 7, again you have 7 observations. So again fourth position, starting from 1.4, 1, 2, 3, 4, 3.7. That's your Q3, third quartile, right? This is your median, X bar, and where is Q2? Yeah. Q1, negative 1.5, Q2 is 3.7. Okay, Q1, Q2, Q3. Okay, what happens if we have even number of observations? It's the easiest thing. It's the easiest case because to find the median, yeah, problem, because once you get the n plus 1 divided by 2, you will be having 5.5 position, which means I think it is sorted. Yes, 1, 2, 3, 4, 5. 21 and 28 get the average of those two values, which means median is 24.8. Okay, first half. Now, since you have even number of observations, you don't have to add the median to you for the Q1 or Q3 calculations. Clear? So that black green color box, do the calculation separately, and this yellow color box, do the calculation separately to find the Q1 and Q3 respectively. Okay, clear? So Q1 is 14 and Q3 is 39. So Q1, Q2, Q3. Okay, there is a very important summary we call 5-number summary, because once we analyze our data set, this is the easiest thing you can see. 5-number summary. There are 5 things: minimum value, Q1, Q2, Q3, and the largest value or the maximum value. Minimum, maximum, and those 3 quartiles. Okay, those are those 5 we call 5-number summary. Okay, so if any case I have mentioned, okay, find the 5-number summary, you have to find those 5 pieces. Okay, First and last one is the easiest one. Just sort it. When you sort your data set, you can see what is the minimum and maximum. Quartiles, you have to figure it out. Okay. It is a quick summary of this both set and its variability. Okay. Minimum, maximum, it shows you what is the range of this data set, Q1, Q2, Q3. It shows you how these data observations are shifted. Okay. Uh, Location for qualitative data. This is, I don't know why they have put this into this particular place, but anyway, if we need to find the success ratio, okay, for success, if we need to find the success ratio to the number of observations, we use this sample population. If we are using sample, okay, if we are using sample, we can find the sample proportion, right? Yeah, proportion by taking number of successes divided by number of observations. Simply x over n. We denote it by simple p hat. Okay. If you need to find the population proportion, same thing, number of successes divided by population size, capital N. Then we call it just simple p without hat. Okay. P hat means sample proportion. P means, for this case, population proportion. Okay. It is something like relative frequency value. Successes divided by total number of occurrences or data set, size of the data set. Okay. Here you can see a very small example. Yes, the department wants to know what proportion of their 400 returning students. Okay, so they poll 40 of those students. 28 of them said yes. So yes is the success. So how many yeses? 28. Okay, how many successes? 28. Number of, what is the size of the sample? 40, right? So 28 divided by 40 is the sample proportion. Okay, clear? Okay. Sorry for that. In this part, we are talking about measure of variability. Okay, variability, like how our data set or simply observations are distributed. Like with it is, we call it spread of the data set. That's the word. Okay. Okay. Yeah, importance of the spreadness is this one. You can see two banks. They are measuring the waiting time. Okay, and the number of people who are waiting. So once you check the first one, you can see, okay, waiting time in seconds or minutes, doesn't matter. In the x-axis, you can see the waiting time. It's like distributed very nicely, like 4, 5, 6, 7, 8, 9, 10, something like that. But once you see the last one, you can see it's already start from like 6.5, huge number of people, like frequency is 7 or 8. Okay, so you can see the difference, but I think they have 3, 6, 9, 11, 3, 6, 9, 11, 12. No, 3, 6, 9, 10, 11. Yeah, they have same number of observations. Clear? But they have different shapes. Like first one is like this. The second one is like this. See, that's the very simple example for the spread of the distribution, the data sets, because They have same number of observations, but they have different values. A measure of spread. So the spreadness we measure by using variance and standard deviation. This variability uh, we can measure using 5 number summary as well, but it's not a good measurement. So still we can use 5 number summary, variance and standard deviation. Uh, Variance and standard deviation, they have a very good relationship. Standard deviation is the square root of variance. That's it. Okay. Standard deviation is the square root of variance. Basic measurement, yes, minimum, maximum. We can figure it out if we are dealing with 5 number summary. Range, yes, still we can figure it out from the 5 number summary. Okay. Okay. So first one, variance. Since we are talking about sample, we have sample variance. So sample variance we denote by simple S squared. Simple S squared variance. Okay. So sample variance S squared you can find using this equation. So it is summation of xi minus x bar squared divided by n minus 1. Here xi is the ith observation. Ith observation. X bar is the sample mean. So squared only for the upper half. Okay. So numerator part. Okay. Not everything, just the numerator. Xi minus x bar squared. Then divide by n minus 1. So in any case, you need to find the variance divide by n minus 1, not n minus 1. Okay. So don't mix them up. So you have to get the summation of all the observations by reducing its mean. Okay. So value inside the bracket, that can be negative or positive, but it doesn't matter since you are squaring it, everything positive. So variance always, variance and standard deviation always positive values. Start from 0 up to whatever positive. Okay. I told you standard deviation is the square root of variance. Okay. Okay. Clear? Yes, you can use calculators. No need to do this by hand. Okay. Important fact. Both variance and standard deviation, they are positive. I mean, non-negative values. Positive, non-negative values, including 0. 0 means the all observation have the same value. Yes, they don't have a variance. They have similar values. Unit of variance are the square of the yes, because variance, how we calculate the variance? Squared, xi minus x bar squared. So see, not this one. See, xi minus x bar squared. So squaring, we square is something. That's why they have mentioned here. Variance are the square of the units of data. Once you reduce the x bar, which means the sample mean, you have a unit. Okay, that's what we call something like standardizing. That's the thing. Observation minus your sample mean. Squaring. That's why square of the units of the data, and the standard deviation, since we are taking square root, squared goes away, then it is exactly the unit of the data. Okay. Both are heavily affected by outliers. Why? Because still we are using observation value and the mean. You know already mean is already affected by outlier. So we have value and mean, then again that calculation also affected by outliers. It is heavily affected more than, it is affected more than mean because we are squaring it. Okay, a value when once we square it, it's big, right? If mean is 2, we are squaring it. Xi minus x bar squared. So it's going to be 4, something like that. So we are squaring this error. That's why heavily affected by outliers for the variance, both variance and standard deviation. Okay. I think I can do one slide. Yes. Proportion. Okay. If you have a data set like if you have observations x1, x2, x3, x4 up to xn, and c is a non-zero constant. Non-zero constant. It's not a zero constant. So if you see a relationship like another observation set, you have x observation set here, another y observation set here, y1 equal x1 plus c, like yn equal xn plus c. Likewise, y1 equals x1 plus c, y2 equals x2 plus c, up to yn equals xn plus c. If you have this kind of similarity between those between two observations, you can simply say, okay, sy means standard deviation of the y data set, y observations, and sx is the standard deviation of the x observations data set. Clear? So they are equal. Constant, it's like doesn't matter. Okay? Clear? Which means if we have this kind of relationship and you already know what is sy, easily you can mention what is xx. Okay, what is the standard deviation of x data set. One last thing, this one is the last one for today. If you have this kind of relationship, your y data set y1 equals x1 times constant, constant times x1, y2 is constant time x2, yn is constant time xn. If you have this kind of relationship, your standard deviation for the x observations sy equals absolute value of c times sx. Why absolute value of c? Because we are considering positive values only. Why it happens? Because sometimes we may have negative values. So to avoid that, we use absolute value. For an example, what is the square root of 25? 5, I sure. So what about negative 5? Negative 5 times negative 5, it is 25, right? So that avoid that kind of misunderstanding, we use absolute value. Okay, because we are dealing with square root of variance. Okay, so that's why we use this. Sometime you may need this, not every time, but sometime it is easy to, if it is easy, if you figure it out this, you can simply give the answer. Okay.